Good evening, students. So today we will discuss about the topic electromagnetic spectrum. So yesterday we have seen electromagnetic radiations. So electromagnetic radiation will contain wave nature. So electromagnetic light means electromagnetic radiation means light. Light contain the wave nature, and we have seen measurable properties of the waves, that is wavelength, and wave number and frequency and energy. So all the measurable properties we have seen. So in that measurable properties, one more property is remain, that is amplitude. Amplitude means what? So the height of the crest or depth of the trough is called amplitude of the wave. For example, this is a wave. So this is a wave. So this height of the crest or depth of the trough. So this is called crest and this is called trough. So this distance is called amplitude. So as the distance of amplitude increases, the intensity of the light also increases. So intensity means brightness of the light. So if amplitude is more means the light is more bright. So brightness of the light increases with increase in amplitude. Next, electromagnetic spectrum. So electromagnetic spectrum means the arrangement of different types of electromagnetic radiations in the order of increasing wavelength or decreasing frequencies. So if we arrange different electromagnetic radiations in order of increasing wavelength or decreasing frequencies is known as electromagnetic spectrum. So this electromagnetic spectrum here, so gamma rays contain minimum wavelength, lowest wavelength and highest frequency, and then X-rays, and then UV, and then visible, and then IR, and then microwaves. So here I forgot to write the visible light, so you add this visible light in this range, so in this order. So gamma rays, X rays, UV rays, and then visible light, and then IR, and then microwaves, and then radio waves, short range radio waves, next long range radio waves. So this is the order of increasing order of wavelength. So here wavelength order increases from gamma rays to radio waves. So means radio waves contain long wavelength, and gamma rays contain shortest wavelength, and highest frequency is for gamma rays and lowest frequency is for radio waves, because both lambda and wavelength and frequency are inversely proportional. So means highest, one is highest means other one is lowest. So gamma rays contain high frequency and lowest wavelength. And next, if you take frequency order, so this is reverse to this order, because wavelength and frequency are inversely proportional. So this is the frequency order. Gamma rays contain highest frequency, and then X-rays, then UV, then visible light, and then IR, and then microwaves, and then radio waves. So this is the order of frequency. So highest frequency is for gamma rays and lowest frequency for radio waves. And this arrangement is called electromagnetic spectrum. And visible radiation. So here what is the range of visible radiation? So visible radiation means our eyes can see the visible light. So the light which our eyes can see is called visible light, and it ranges from 380 nanometers to 760 nanometers. So this is the wavelength range. So value of wavelength from 380 to 760 nanometers. Visible light ranges from 380 nanometers to 760 nanometers. And visible light is produced from stars and glass enclosed in tungsten filament. So the example for visible light. The stars can produce visible light, and glass enclosed in tungsten filament can produce visible light. And white light means visible light. So in visible light, white light contains composed of 7 colors. So white light, if you see, the sunlight is example for white light. So it is produced by 7 colors. So that is called WebGR. So we know that violet to red color. So these 7 colors ranges from violet to red is called. So this is the visible white light contains 7 colors. It's split into 7 colors, which ranges from violet color to red color. So violet color contain maximum frequency, means maximum energy. So high energy is and high frequency is for violet, and minimum frequency is for red. So if you see this wavelength values, violet color ranges from 380 nanometers. So it contains lambda value, wavelength value 380 nanometers. And then indigo light ranges from 430 nanometers to 460 nanometers. And then blue light ranges from 460 nanometers to 500 nanometers. And green light ranges from 500 to 560 nanometers. Yellow ranges from 560 to 595 nanometers. Orange light ranges from 595 to 620 nanometers. And then red light ranges from 620 nanometers to 760 nanometers. So this contain highest wavelength and lowest frequency. So it is the increasing order of wavelength and decreasing order of frequency. So electromagnetic spectrum is increasing order of wavelength and decreasing order of frequency. Then we will see some problems. So the first one is the wavelength of blue light is given, that is 4800 angstrom, and calculate the frequency and wave number of the light. So they have given the lambda value. Lambda value is 4800 angstrom, and they asked about frequency. Frequency is nu and wave number is nu bar. So this values we should calculate. So we know that nu equal to c by lambda, right? So this is the equation, important equation. Yesterday I have said this is very important for solving problems. Nu equal to c by lambda. How it comes? Nu is inversely proportional to lambda. So if you remove the proportionality, the constant c will come. C is the speed of light, or it is called velocity, speed or speed of light. So this is the constant value. This is 3 into 10 power 8 meter per second. The speed of light is 3 into 10 power 8 meter per second. And by lambda value has given, but they are given in angstrom. So we have taken here in meter per second, right? So we should convert this angstrom into meter. And 4800 into 1 angstrom equal to 10 power minus 10 meters. And if you solve this value, it will become 4.8 into 10 power minus 7 meters. So if you substitute these values, 4.8 into 10 power minus 7 and 3 into 10 power 8, if you solve this problem, so you will get frequency 6.25 into 10 power 14 second inverse. Okay, so this is the frequency, and we can calculate wave number. We know that wave number is reciprocal of wavelength. So means nu bar wave number is equal to 1 by lambda. So this is also important equation. Nu bar equal to 1 by lambda. So from this we can substitute that lambda value 4.8 into 10 power minus 7 meters. So we will get the wave number 2.0833 into 10 power 6 meter inverse. So the blue light contains frequency 6.25 10 power 14 and wave number is 2.033833 into 10 power 6 meter inverse. And then so one more problem. So the wavelength of a radiation emitted by a sodium lamp is 600 nanometers. They have given the wavelength lambda is 600 nanometers. Find the frequency. Very easy. Nu equal to C by lambda. Just substitute the values, you will get the frequency. So here lambda is given 600 nanometers and we should convert it into meters or centimeters. So if you take 3 into 10 power 8 value in centimeters, that will become 3 into 10 power 10 centimeter per second. Okay. So if you convert it into meter, we should take the C value in meters. So 600 into nano means 10 power minus 9 meters. And then nu equals C by lambda. We know C value is 3 into 10 power 8 meter per second. And by this lambda, we will get the frequency of the light. This is the answer.